you? My name is Chabulani Chitanga. So I'm recording this video to show you how do you run analysis manually that for dependent and reflected samples, sometimes for matched samples t-test. So there is independent t-test, and then there is also dependent, related or matched sample t-test. So this video I'm going to make short. So I wrote it down so that I don't waste much of your time. Just follow the steps that I want to show. So the focus of this video just show you how to do the calculations. I ignored the steps involved in decision making, like for example, stating the hypothesis, allocating the critical region, and then so I'm focusing on the third step of the calculation, depending on the textbook that you're using, and then the final one where you make a conclusion. So I'm going to share a screen with you. Enjoy. So I took this example from a textbook. So this t-test for repeated dependent or meshed design. So it's from experiment that they use the same group of participants in both of the treatment condition. So when you read or when you watch the video on independent t-test, you see the difference around participants here. And then the treatment and then the groups that are being compared. So t-test for comparison purposes, we're comparing the mean for the people. So what you want is an inferential statistics whereby you want to compare the populations, but we use a sample. That's why we use the population mean in the hypothesis. So in this example, that there is a different people when they count money and then when they count papers. Is it this one? Yeah, I'm not sure. NA and CA, I think so. So in the question, so these are the scores that we have, and then so in the assessment that you can have from wherever you are studying, you get scores like this. Sometimes they are written in a vertical format. Sometimes you are given in a horizontal format, and then sometimes you are told to use two-tailed or maybe non-directional tests, but sometimes you're not told. So it depends on the way the question is written. And then you're also given the significant level. Sometimes we don't write 0 here, it's just 0.05, but just for control, I wrote like this. And then, so it depends on the question. So you must be careful how you read the question. Is it a two-tailed? Is it not? Is it a one-tailed test? But like what I said, the focus of this video is just to show you how to do the calculations. Okay. So like what I said earlier, you follow the steps depending on the test. Some textbooks they follow the 7 steps, but the one that I took is from the one that I'm reading now. They follow the 4 steps of hypothesis. So you must write the steps clearly, please, as clear as possible. The first one, hypotheses. So you state the now hypothesis and the alternative hypothesis very clearly. And then the second one, you locate the critical. In this instance, is n-1. So we have 1, 2, 3, 4, 5, 6, 7, 8 participants here. So -1. So the degrees of freedom is 7. And then you check under two-tailed at the back of a textbook in the critical, the t-distribution table. And then you obtain a plus or minus. There's a plus or minus because it's a two-tailed. So you are going to get 2.365. We are going to make use of this value as we move forward. So now the third and the focus of this video is to calculate the T for dependent t-test. So the formula for that is MD. M is the mean, so the mean difference, and then this is the population difference, of which is 0 because the null hypothesis say that there's no difference. Okay, depending on the. And then the denominator of the equation is the estimated standard error of the mean difference. Okay, so that's what we want. But for you now to do that, let's say these are the scores. How can you do that in an easy way? So you can arrange the scores like this. So you can create 1, 2, 3, 4 columns. That's easy. And then you arrange your scores and then the difference. And then please note that you can do it 7 minus 10. Can get -3. So you can do it vice versa depending on the question. Sometimes the question is concerned like maybe before the treatment, after the treatment, maybe let's say we introduce an intervention, we expect a decrease of something. And then sometimes we introduce an intervention, we're expecting an increase of something. So the way that you subtract, it doesn't matter. You still get 24. But depending on the way that you subtract in terms of maybe 7 minus 3, so this will be a negative 24. But what we want to do as a hypothesis is that difference significant? So you don't get, it's not a big difference than the value that you get here. But it's going to be 24. If you do it vice versa, it's going to be minus 24. So these scores are the differences of 7 minus 3, 4 minus 3, like something like that. And then you square the difference. I'm going to make use of this when you calculate our sum of squares. So you square 3 times 3, that's 9, 4 times 4, minus 2 times minus 2. When you multiply the negative numbers, it becomes a positive, and then something like that. And then when you add the total is 218. And then the first step under that, what you do, you calculate the mean for the differences. So the difference is this. So 24 divided by the number of participants. So 24 divided by 8, that is 3. So that is the 3 that we're going to put here. And then here is 0 because our hypothesis is saying that there's no difference. So it's going to be 0 here. And then the second part of towards the equation, you have to calculate the sum of squares for the d. So sum of squares means that sum of squared d's, okay, it means that sum of squared d scores. So this one, the sum of it, that's 218. So it means that 9 plus 16 plus 4 plus something like that, that's 218. And then sum of d, which was this one, that is 24. You square that divided by n number of participants, that is 8. When you proceed like that, you get 146. We are calculating that because we want to calculate estimated standard of error. For you to calculate estimated standard of error, you need variance. So for you to calculate variance, you need sum of squares. That's why we're doing that. So for variance, for sample variance, so it's SSD that we calculate divided by n minus 1. That is 146. This is 146 divided by 7. So it's like the degrees of freedom. And then the answer that you get is 20.86. And then now the equation for estimated standard of error, move forward, is in a square root, variance divided by n. So the variance that you obtain is 20.86. So we divided that by 8. Please don't forget to, most of the students, they proceed and then they forget to include this square root, and then they get the wrong answer. Please be careful about that. So 8 divided by whatever, you get 2.86. Some students also, they make a mistake by saying 8 divided by 20.86, of which is vice versa. It's 20.86 divided by 8. So when you punch in the calculator, please be careful. And then 2.86 square root of that is 1.62. So that is estimated. So this is the bottom part of the equation. And then you proceed. So the 3 that you obtained, the mean difference minus 0 divided by estimated standard of error. So the answer is 1.85. So it can be plus or minus 1.85. So that is T obtained. But what we do with that, because we want to test if that difference is significant. So what you can do, you can compare, you can use this normal distribution like what I drew here. So this is the critical value that you obtained earlier, the plus 2.36. So if any value is in the critical region, you reject the null hypothesis. And if any value is here, so this 0, 1, 2. So the value that you've obtained now, the 1.85 is somewhere here. So it's in we fail to reject the null hypothesis and conclude that there's no significant difference between the two conditions. Okay, and then when we obtain a significant difference, you proceed to calculate the effect size. So you can use estimated coins D